particular subject directory created by a library that I will be covering. But first you see in the slide that the generic or open directory project, which is called Demos directory, and here you see the difference between a subject directory and a search engine. A subject directory includes a search interface along with the different kind of categories. Here you see in the slide the Demos divided the universe of knowledge into categories like arts, games, kids and teens, references, etc. Now it's a generic subject directory. It includes both commercial resources and academic resources. Now let me introduce you with the subject directories created by the librarian and very effective for discovering different kind of scholarly resources. The first one is the LII or Librarian's Internet Index. Here you can see in the slide that the whole gamut of knowledge they divided into different kinds of categories along with the simple search interface and advanced search interface. I request you to explore this Librarian's Internet Index that is available from the web URL lii.org. Now another subject directory created by the librarians are called IPL2, that is the IPL version 2. This is basically the Internet Public Library, and here if you see the interface of IPL, here you can, if you click the resources by the subject, it will generate number of categories, and if you click a particular category you will be getting the subcategories, and within each subcategory number of resources available will be written within parentheses. So please tell your user that first try to retrieve a small set of relevant document by using different subject directories like Demos, LII or IPL. Then after accessing these resources, after studying these resources, you please come to the search engine to collect different kind of other informations. And most of the cases people search Google search engine, but there is life beyond Google. There are many search engines apart from Google. So whenever you are selecting a particular search engine for discovering web resources, please focus on the following issues. That is the size of the database. How big is the search engine? That is the freshness or up-to-dateness. How current the resources. Completeness of text. Type of the document included in search. And what is the speed and consistency of the search engine. That is the first group of factors you need to consider. In the second group you need to consider, as you can see from the slide, that what are the basic search options and what are the advanced search options available from the search engine for pinpointing your search. What are the general limitations and features of that particular search engine. And in the third group you need to know what are the ranking method or ranking algorithm followed by the search engine, how it displays the retrieved set of results, and whether it allows you the feature like collapsing of pages or navigation or clustering of searches. So these are the few factors you need to consider before selecting your search engine. But as you can see from the slide that this is your most favorite search engine, Google, and most of you people are using this. Now suppose in the first screen snapshot, that is the blank Google search text box. And in the second text box, in the second snapshot, we represented or we have given a query to Google. A very simple query, environmental pollution. Most of the cases we search like this. Now you see, if you closely look into the slide, you see the moment I have given the search query environmental pollution, it retrieved the number of result which is reported just below, which is highlighted, that is 1,75 lakhs. So within 0.34 seconds, Google retrieved 1,75 lakhs of document related to environmental pollution. Now you ask a very simple question to yourself, that is it a kind of good information retrieval system? for any word query, if a particular system telling you that there are more than one course of documents available on the topic, and in most of the cases we do not move from set 1 to 2. That means Google actually represents different kind of results into sets. Each set contains normally 20 documents, and people normally do not go beyond set number 1 or set number 2. So this is a big limitations of search engine. It's not only the limitation of Google, it's limitation of each and every web search engine. You enter something, you search by something, and the search engines retrieve a huge set of retrieved documents, which is basically impossible to follow. That's why normally we do not go beyond set number 1 or 2. Now you compare these search engines with your library system. In a library, you can search a book by the author, by the subject, by the title. Can you search or can you extend that kind of techniques in case of a search engine like Google? So that is where a library professional can take the lead, and they can teach users that how to use search engines more intelligently, more professionally, to retrieve a highly set of relevant documents from a big reservoir of information resources intelligently, professionally, and effectively. Now let us consider the special keywords given by Google. There are number of special keywords which are actually provided by the Google search engine. You can have those keywords in the Google help file, but 3 to 4 special keywords, if you learn properly and if you can teach your users, then it will be very beneficial for you as well as your users. So here I will be showing you the application of 4 special operators in Google search engine, and you see the magic, how intelligently we can retrieve the most relevant document within a few seconds. So first operator what I will suggest, that is called the phrase operator. You see the first slide, or the picture in the first picture in the slide. So here you see I just include the environmental pollution within phrase. That means I have instructed Google to retrieve only those documents where environmental and pollution came side by side as a bound term. And you see now Google says that the result number of relevant results is around 56,50,000. So here you see, the moment we enclosed the multi-worded term environmental pollution within a phrase, Google restricted the result from 1,75,00,000, it reduced to 56,50,000. So it's working actually. So my suggestion is that whenever you are searching a multi-worded term or documents with multiple keywords, always enclose the related multiple keywords within phrase, that is inverted code, that is called phrase operator. So you are searching the query as a phrase. Now the second most important operator I would like to introduce, that is called all in title and in title. Just before that, let me give you one example. Suppose there are 3 documents on environmental pollution. In one document it came in the title of the resource. In the second document it came in the abstract, and in the third document it came in the body. So you can easily imagine as a library professional, the first document where environmental pollution came as a phrase in the title of the document is basically the most relevant of these 3 resources, where then in the second one it came in the abstract, in the third one it came in the body. So the first one, that is the resource where environmental pollution came in the title, is the most relevant one. Now the question comes, can we instruct Google to retrieve only those documents where environmental pollution came in the title? There are 2 types of special keywords for each. If you are searching a multiple word, that means you need to give all in title special keywords. and if you are searching a single word, you need to give in title special keywords. Here you see in our cases, in our example, we are searching environmental pollution as a phrase. It's a multi-worded term. So we have given, in the second picture you can see all in title colon and within quote environmental pollution, and this time you see that Google retrieves only 75,300 results for this particular query. That means only 75,000, around 75,000 resources includes environmental pollution as a phrase in their title. So definitely this 75,000 is the most relevant one, in the first set Google retrieved, that is 1,75 lakhs. So from 1,75 lakhs of document you reduced your the retrieve set into 75,000. Now many other filters you can add. As you see that most of the academic resources in the web not available in HTML format. They are either available in PDF format or doc format or PPT format. Now can we restrict that Google should retrieve only PDF files, only doc file or only PPT file for us? Now here the special keyword, as you can see in the slide, the first image, file type colon. So here I have given file type colon PDF. That means you retrieve the documents where environmental pollution came in the title, then the file type must be in the PDF format, and Google retrieve 5,790 results only. And you can extend this to many other formats. Say for example, if you want to retrieve only Word file, you give file type colon PDF doc. If you want to retrieve only PowerPoint slides, give file type colon PPT, and so on. And most importantly, again you can add a filter to retrieve results from a particular country. Here you see in internet we follow the domain name system. Either it's a generic top level domain like .com, .net, .edu, etc., or a CCTLD, that is a country code top level domain where each country is represented by a 2-letter alpha code. Say for India it is .in, for Pakistan it's .pk, for Bangladesh .bd, for Japan .jp, and this is based on a particular ISO standard called ISO 3166. So if you go to Wikipedia and display the standard ISO 3166, you will be getting the entire domain name of different countries. Now you can utilize that domain name to restrict results from a particular geographical area. Here suppose I want to restrict my search environmental pollution only for those documents which are originated from India. So here I will be using, as you can see from the second image of the slide, I will be using the special keyword called site colon, and there I need to give the domain name of the country. So here it will be site colon in. If it is for UK, site colon UK. If it is for Japan, site colon JP. If it's France, site colon FR, and so on. Now here you see magically for this particular query Google retrieves only 282 results, and that very much navigable. That means now it's impossible for a particular searcher to search or retrieve 1,75 lakhs of document, but 282 is a positive set of result what we can go through or we can study. So in this way, by using only 4-5 special keywords, you can retrieve most relevant documents from a big or large pool of information reservoir by using different kind of special keywords. You please apply for your personal retrieval, as well as a library professional you teach this to your users so that they can retrieve information from the web very easily and very quickly. Now here you can see that Google and many other web search engines are also Unicode compatible. That means you can search your query in any Indic script like Bengali, Oriya, Hindi, Gujarati, etc., and search engines can give result in that particular language. Here you see I have utilized a virtual keyword, virtual Unicode compliant keyword to search Rabindranath Tagore, and these are the result given by the Google. So is the Yahoo. Google Scholar you can use. Another important feature of Google Scholar is that you can retrieve lot of cited documents related with your query. Say for example, the moment I search by a particular author name, it gives all the papers available in the web, and at the same time it says which paper is cited by whom and how many times. So this is a unique feature as far as scholarly resources are concerned. Try to use Google Scholar and try to teach this tool to your users. And the most importantly, all the special keywords, those are applicable to the Google generic search engines, are also applicable to Google Scholar. Please remember that. Now there are many other search engines, Kyle, for the different domains. Say for example, news search engine, book search engines, and another interesting thing is coming in between, that is called the visual search engine. That means you see previously that the interface between you and your search engine is simply a text box. Now the next generation search engines can retrieve results visually. If you see the slide here, you see I have searched this particular visual search engine called Cut2.com by the term nanotechnology, and Cut2 retrieves result not in the form of text but in the form of a visual map where most relevant resource placed in the central position. So possibly this is the future of searching, where document or the result will be displayed in or visually